sound of Universal Broadcasting Network at UBNradio.com.
One of them wanted to be the security guy. He claimed he was a security guy.
Welcome once again to a connected version of Security Guy Radio. Mr. Jarvis, how are you?
I'm good.
Get your mic on there now. Now, I might not want your mic on all the time because of that radio voice of yours, which is superior to mine. There you go.
Yeah, I know. I'm sorry.
It's unbelievable. We got to get your own show.
Yeah, I do.
You do. You got it. Everything been good?
Yeah, everything's good.
Mr. Tony is a little under the weather, but we're wishing him well.
But he's doing well. If he's on Periscope, so he's fine.
Yes, he was broadcasting from his bed at an undisclosed location, so I think he's doing good. Well, we're going to have a friend of mine back in the studio here who was at As Is, right? And we're going to talk about connectivity. Now, remember last week we talked about mobile data breaches and all that kind of stuff, right? This is not that, but we're going to talk about it in connection with what's going on with internet and connections and all that kind of stuff. And we're going to welcome our guest, Mr. Eric Dorden. How you doing, Eric? Alex.
It's all right. Hi, Chuck. Thanks for having me.
Welcome back from Siklu.
Appreciate that.
Right.
Yeah.
So we spoke last at As Is, I think, right?
Mm-hmm. That's right. Yeah, Anaheim. Yep.
And tell us what your product does, because this is really a new thing. It's fascinating to me, and I want to make sure I get it right. Now, look at the camera. You look a lot better today, right? Because when you were at As Is, what happened was I had the GoPro, and it got set to ultra-wide morphine something or other.
Okay.
Remember, and it kind of stretched the image and stuff?
Yeah.
So we're going to do a reshoot, so you look a lot better today.
Right,
So I appreciate that.
that.
So tell us what your product does, Siklu.
Yeah. Okay. Sure. So we're in the point-to-point wireless connectivity kind of space. So what we really specialize in is connecting 2 points together wirelessly. So if you don't have a fiber connection, for example, we're providing very high reliability, 5 nines worth of wireless connectivity.
Now, can you make my Samsung VCR talk to my TV? Because I couldn't watch House of Cards last night. And I'm half kidding, right? I'm thinking, what's with the technology, right? I mean, we can do these things you're doing at a really high bandwidth, and I can't get my freaking VCR to work. But let's talk about what that problem is in the industry. So we had somebody, like I said last week, talking about mobile connectivity.
Okay.
Let's talk about the security aspect of this. I'm concerned because of the connectivity, right? And when you say wireless, people get a little nervous, but yours is different. We're not having that problem with your product because why?
Right. Well, a couple of reasons. First of all, we play at a higher operating bandwidth than most of the wireless network connectivity companies, so we don't suffer from issues with interference or congestion that you'd find particularly in cities from Wi-Fi, for example, or really pretty much any other wireless kind of device. Even cars now are built in wireless. There's Wi-Fi absolutely everywhere.
Right.
So there's a lot of problems with interference, a lot of problems with congestion in that space. And we operate at a higher operating bandwidth, which does not suffer from those kind of issues with congestion.
Define congestion for us. Is this the issue, to boil it down for my nieces and nephews, something very simple? Is it that, I can't get on LinkedIn and Facebook at the same time because either A, Verizon doesn't want me to have that much bandwidth, or it's bumping into each other. What causes it?
Well, there's two things, and you hit it on the head really. It's very similar with your cell phone. You're losing Wi-Fi connectivity because there's too many users, too many people on there. They kind of people are vying for the same amount of space, if you like. So that's the kind of one issue. So you get bumped off, if you like, and the other one is issues with bandwidth availability. You're trying to stream video. And there's delay, there's lags. You can't stream it just because insufficient bandwidth. And we solve both those problems with our product. We solve the problem with interference because we're a high operating frequency where we don't have interference, and also we have a much greater throughput capability. We can deliver up to 2 gigabits per second, full duplex.
2 gigabits a second.
2 gigabits per second. That's right. Absolutely.
Wow.
I mean, for obviously typical camera system, you may not require that. Certainly not for a small number of cameras. But when you're backhauling, a large number of cameras, particularly talking about 4K cameras, which all need a lot higher, bandwidth capability, we can deliver that with no problem whatsoever.
So, Mr. Jarvis, it takes me 3 hours to upload Security Guy Radio to YouTube. And it's less than 2 gigs, by the way.
Really?
Yeah, he just said 2 gigs in a second.
That's right.
Think how many more shows we could do.
I know, right? Wow.
Now, is that something I'm going to use as in my business? Would I use that? Is it cost prohibitive for me to use something like that? or is this really more high-end industrial, giant corporation kind of use for your product?
Yeah, I mean, our use cases kind of vary quite a bit. I mean, it's all pretty much outdoor. We're
Right.
most of what we do is outdoor. It's all point to point, but it could be linking two buildings together, for example. It could be linking a parking garage, for example, to a building.
If you're reading your parking machine that's transmitting entry data or that kind of thing. Okay.
Yeah, I mean, a parking garage you could have access control, exactly,
Right.
entry exit. You could have cameras in there. You could have emergency telephones. A host of different applications, or even Wi-Fi. And you want to bring it back to a building where you got your fiber pop. You want to bring it back to fiber, and either putting in additional fiber, putting in additional fiber connection to that parking garage, for example. You can do it as a wireless connection instead.
Now, am I correct in calling it wireless? Or I remember at the studios we had something, I think it's called microwave technology. There was a microwave signal, which is more like a radio signal, I guess, right? And that connected a couple of our studios together.
Right.
Is this something similar? This is not really Wi-Fi per se, is it?
No, it's not
Right,
Wi-Fi.
okay.
Wi-Fi is kind of like very broad. People can use it for mobility, for example, and also your phones, or
Right.
your laptops, whatever it is, your tablets, We're in the point-to-point, so it's not a mobile kind of application. It's a fixed application. I mean, it could be temporary. We do temporary applications as well. For example, our radios we use in the New York Marathon, for example, in 2000.
Oh, yeah, a mobile setup for a temporary event. It's
Exactly.
high res,
Temporary events.
it's secure, it's a high bandwidth. Yeah, okay.
Yeah, and you mentioned security. It is very secure. I mean, we offer AS encryption, for example, for added security. But because the beam angles in our type of technology is very, very narrow, it's very directional wireless, it's not broad, it's impossible to hack into, impossible to kind of intercept a wireless transmission with our type of technology.
Now, point-to-point is explained such as, I got one building in Fox and I want to connect to my other building down the street. That's a point-to-point connection. Is that behind my network, behind my firewall, behind my protection inside the studio, or is that a separate network outside of my studio network?
I mean, it depends. I mean, if you kind of on your own network, so you have a network, with switches with various devices connected to your network. Basically, what we're providing is what we like to call a fiber-like wireless connection. So rather than connecting, the two buildings using, Y connection,
Right.
copper or fiber, we're doing it wirelessly.
Or connecting them through the internet,
Right.
which has problems, right? I mean, you
Exactly.
can have some kind of hacking in between those two connections
Yeah.
on the broad network.
Yeah.
Is this application available for a medium to small business? And is there an entry point for cost that I would say, I got a radio station here. We want to send it from this studio over to our studio in West LA. I mean, would that work for an application for something like this?
Yeah, I mean, the kind of projects, applications we're involved with sometimes are only a single network connection, and it could be a building connecting two buildings together, for example, like a campus type environment,
Right.
or as I said, like a parking garage. We do a lot of those in cities, for example, or it could be a citywide kind of application. So, for example, towards the end of last year, we did a couple of city surveillance projects. Fort Myers in Florida, which is a 100% wireless system, linking multiple cameras together, back to the police department. They had no fiber, so they had to do it
Right.
wirelessly. They had to do it in a short space of time. So they went with a wireless solution. Vail, Colorado is one we did last year as well. We're currently working on a project in the Port of Long Beach. With wireless, and again,
Oh, they have all kinds of interference down there. It's
absolutely,
terrible.
yeah. And that's one reason why they chose Siklu, because the technology that we're in, which is called millimeter wave wireless, doesn't have those issues with interference or congestion.
By the way, are you one of the few people, or the only person in this space, this device? It's about a year old, this technology, a couple of years?
Well, the technology's been around for about 20 years. In terms
okay.
of millimeter wave, it's been around for 20 years, but it used to be very expensive. It used to be like $25,000-$30,000 for a single link.
Oh,
you know?
wow.
Siklu, we came onto the market in, the company was founded in 2008. A couple of years later, we brought the product to market. And we were able to bring the price of the technology down considerably. We developed the world's first all-silicon-based radio card, and we were able to bring the price down to, $5,000 MSRP for a link. and within a couple of years, we became the market leaders in this technology.
Oh, that's fabulous. So $5,000 to install it, set it up, or is it?
Well, that's that's like for the actual link, and then obviously the cost of installation and everything else. But that's roughly MSRP. Is actually the prices are coming down all the time now because obviously benefit from economies of scale, new technology, things like that. So it is actually becoming more and more affordable, even for just small systems with a small number of cameras in a parking lot, for example, where there may be issues with interference. You may not require the throughput capability of our technology, but you want a high reliability wireless network connection, and compared to putting in fiber, for example, the pricing is much lower, and the return on investment is much greater, much quicker.
On fiber, I think you can have 20 devices, 30 devices, or something per strand, or something like that. What's the analogy on your device that how many things it can carry and all that kind of stuff?
Yeah, I mean, really, it depends on obviously the throughput per device, the bandwidth per device. For example, if you're using multiple 4K cameras, it depends on the throughput required per camera, but we can support literally hundreds of cameras, for example, on a single wireless link. Said we are up to 2 gigabits per second, full duplex, 2 gig in each direction, upload download. So there isn't really any issues with bandwidth or throughput capability with our solution.
I can see this in a police department. Any applications where a police department has adopted this for their entire dispatching platform?
Yeah, we've done a few projects with PDs around the country. For example, we did a parking lot up in a police station up in Pennsylvania where they had issues with congestion. They wanted video around in the parking garage, so they chose our solution for that. I mentioned cities already. Public safety cameras being connected wirelessly on our application. So we work with a number of PDs around the country, also down in LA. Our technology is being used in Venice Beach, for example, by the PD down there.
Now, what about the wireless cameras the cops are wearing now?
Right.
Part of the problem is the storage. What's LAPD going to do with 1 million minutes, right? Per week or whatever it is.
Yeah.
That's a storage issue. But now I think the images are being stored locally. Mm-hmm. Could your device use that application to transmit this data in real time? And so now we don't have to worry about it not making it back to the police station, getting damaged, that kind of thing. Would that be a good application?
We would work alongside other technologies in that area because we're not really in the mobility kind of area.
Okay.
So we would provide the backhaul to a mobility type application. I mean, we did something similar in Vail, Colorado, where they wanted to provide free Wi-Fi in the town for residents, tourists, things like that, as well as video surveillance for public safety. So we're actually providing the backhaul for both the Wi-Fi as well as the video surveillance. So there's no reason why using those Wi-Fi access points or something similar to that couldn't be used for downloading the video data from the body-worn cameras that the police are using.
Yeah, so with 2 gigabytes a second, it's going to be done.
Right,
yeah.
Exactly.
Now, what's the range on point to point?
The range is roughly up to about 2 miles.
Really?
It kind of a little bit, yeah. It
Wow.
depends a little bit on the areas going into because it's subject to interference from rainfall. So it's kind of longer distance in low rainfall areas, short distance in high rainfall areas, But typically we find in a city kind of environment, most applications are less than 2 miles anyway.
Why does the rain interfere with it? What's
Because it's called millimeter wave wireless because the size, the frequency is very, very small. It's millimeter wave, which is similar kind of size as raindrops, if you like,
Oh, interesting. Okay.
So rain, it's called rain fade. So heavy rain will, basically minimize the distance. So it's about 2 miles. Now that depends on the level of availability you want, level of throughput you want. We can go further, but then you may get lower level of availability or lower throughput capability, if you like.
Now, this is a really small device physically. It's not a big giant thing.
Right.
Maybe, Jarvis, we could show a couple pictures here.
Yeah.
You could look at that screen there, Alex, and you can tell us what we're looking at there. So this is... There we go.
Yeah, so that shows. That's actually an image from Fort Myers in Florida, where they're using access communications cameras, video surveillance cameras, the latest 4K cameras, and they've actually got 70 megabits per second coming off each pole. They've got 3 cameras per pole, and they needed a high quality, high bandwidth wireless solution, to bring back the video from multiple camera locations to PD. And they did that using our radio. So yeah, you got a few of the images of some of the products. The product's very, very small.
It's very small.
size.
It's like 1 by 1 foot. square
It's,
foot?
it's smaller than that actually. It's
Oh.
about 6 inch by 6 inch diameter.
Really? Wow.
Yeah. So it actually doesn't look like a radio. It looks almost like more like a junction box kind
Yeah.
of thing, a NEMA 4 enclosure kind of thing.
And what is that powered by local power?
It's
Battery
it's,
backup,
it's PoE powered. So as long as you got PoE power there. We got some customers who run it off solar. So if you've got a
interesting.
solar kind of application, if you don't have power, or if you don't have continuous power, you've got a lamppost, you can put a continuous power bridge in to power the radios.
So it doesn't
They're
need a
all
lot
low
of voltage or watts or whatever to run it.
No.
Which is great if Armageddon and the zombie apocalypse comes. You can keep some connectivity in your business,
Right.
If you have backup power.
Yeah.
That's interesting.
I mean, it's actually, and you've touched on a good point. It's a great backup, if you like, for fiber. So,
Yeah.
if you've got a client with a, critical infrastructure type application, and they may have fiber going to the building, but fiber is also, subject to either being cut, by
Sure.
digging up the road or flooding or rats, things like that. Wireless is a good, application for redundancy, if you like, to fiber.
It has a military feel to it, to me. I'm hoping our military uses this kind of thing because it's resilient, it's point to point, it's secure, it works, right?
Yeah. I mean, it's not what I would call, domestic, if you like, or consumer grade. It's
Right.
definitely industrial, professional grade. Mainly because of the, the throughput capability, the reliability point of view. Yeah, absolutely.
You get a picture of a close up on the box up there, Jarvis, so we could take a look and see.
Yeah, that's right. You can see it. Yeah, that one there. We have both
All
of
right.
those. Yeah, it gives you an idea of the size. Very small, very discreet.
That's amazing.
And this particular radio, it operates in the 60 gigahertz frequency, which is license free, so you don't need a license for it.
Oh, why is that?
Well, it's an FCC regulation.
Right.
Basically, you don't need a license for the frequency. But because the beam angles are so narrow, you're not going to get any issues with interference or congestion, even though it's license free.
So, Jarvis, I think we should think about transmitting Security Guy Radio on this frequency. Maybe get it out to more people that way.
We can certainly help you with that.
Now, let's talk about congestion. When will Siklu reach congestion? Now, you're not congested, but in theory, could this happen?
That's a very good question. I get asked that quite a bit. People say, okay, well, the operating bands you operate at currently aren't congested. What about
Right.
10 years or in 20 years time when your technology is prolific, being used in lots of different applications. Well, there's a couple of things about that. First of all, the beam angles are very, very narrow. So even if you have an area of flood with 60 gigahertz, for example, you're still not going to get problems with interference because the beam angles are so narrow. It's almost impossible to interfere
right.
with each other.
That's good.
And also, the radios support multiple non-overlapping channels. So even if you have multiple radios, if you like, all point in the same direction, all you do is select a different channel, then they wouldn't interfere with each other.
Now, could you link these together? And if I get a 2-mile range on, box A and B, can I stick box C 4 miles downrange and make a chain?
Yeah,
You
absolutely.
can. Okay, that's interesting.
Yeah, you can daisy chain them together.
Yeah.
And by the way, the 60 gigahertz, that's a license free. That's more short range. So the box we just showed you
Yeah.
is about a third of a mile range. And then we're also operating the 70, 80 gigahertz range, which is up to 2 miles. That does require an FCC license. It's a very low cost license.
FCC license, or like a radio station license.
Right.
Similar kind of licensing.
Yeah, I mean it's $75 for 10 years for a license, so it's almost low. It's almost no cost. Very low
Jarvis, we got to
cost.
get one of these.
Yeah, no.
I'm telling you.
But yeah, you can join multiple radios together, create a kind of daisy chain. We've actually got a shot as well showing a typical application with Siklu in it. There you go. Yeah, that kind of
All right.
shot. So we do.
So what are we
both.
looking at here? What is that?
Basically, it's showing both street level application where the small boxes are on a lamppost, for example, and that could be connecting not only cameras together, but it could be Wi-Fi, Wi-Fi hotspot, for example, and that's becoming more and more interesting application, in this market.
Yeah.
As well as your kind of like your longer haul, back haul, maybe connecting buildings together or bring it back to a PD, for example, or a city hall. So yeah, you can definitely. Connects different technologies together, and you mentioned, for example, the body worn camera. So at the street level, it could also be used for downloading, the data off the body worn cameras to backhaul that also.
So I did my Route 66 tour a couple months ago now. And I drove from LA to Chicago on Route 66. And if my phone worked, 70% of the time I'd be amazed. Right? It was,
Right.
changing towers, blah, blah, blah. So I understand this is a different technology, right? It's not really Wi-Fi, and it's not going to run phone networks and things. But why can't some of these Wi-Fi networks use this kind of technology to set up, I don't know how to describe it. I mean, a more resilient backbone for certain applications. I mean, I could see it being incorporated, and you pay a premium to get your connection for something specific, right? I mean, I would love to have the ability to upload 2 gigabytes a second. It would make my day a lot easier.
Yeah.
But it's not. Could those two technologies be worked together and merged?
Yeah, absolutely. So we see a future where cities are becoming wired, if you like, or smart. So a city could be 100% wired in terms of Wi-Fi capability,
Right.
other devices, not only Wi-Fi, but obviously video surveillance for public safety, but it could be other things as well, like parking meters, for example, road signage could all be wired together, all could be very intelligent, maybe diverting traffic, things like that, and obviously with all that data, you have to have a very reliable, robust network to bring all that data back,
Right.
So in that regard, you'd use a millimeter wave, wireless for the backhauling side if fiber is not available. Obviously, fiber is always the best solution. If you can put in fiber, great. If you have fiber available, but you don't have fiber available everywhere. Particularly what we call the last mile type of connectivity. So then you're working with other technologies. It could be video surveillance, access points for Wi-Fi, for the body-worn cameras, etc., to bring all that data back.
Now, explain to me why this can't really be hacked. Let's get into that, because this is a big problem now. And when people say, "Oh, I was hacked," what it really means is you're an idiot and you left your encryption key somewhere where the guy on the network could find it.
Yeah.
I don't have a giant Cray computer at home where I can sit and run code and break your encryption. It's going to take me 100 years, right? And this is the argument with Apple. Apple's saying, well, we made these things secure and we didn't go out and make a public key to unlock it, and that's why you can't get into it, right?
Right.
So that's hacking. Am I close on that, by the way? Description of hacking. That's how hacking works, really. I
that's
mean,
right.
you got to have the key to break the code. Now, they can get into networks other ways. That hacking is made because you didn't have encryption and you didn't have a password and you did a bad password, right? That's a different sort of hacking. But breaking encryption, no. So why is yours not really hackable? Explain that, because I think that's a really important point. People are very concerned about this. I mean, if I get a private radio signal going building to building, and it's a teeny little box, and I'm thinking like a security director now. What's going to prevent somebody from climbing up the pole and opening my box and sticking something in there and capturing the signal?
Yeah. Well, so there's 2 levels to it, really. Even just without encryption, and we offer AES encryption as a license. You know what I mean?
Okay. So some people don't choose that?
Well, it depends on the level of protection required, if you like.
All right.
So AES encryption is always good, particularly for critical infrastructure, public, things like that, if they really want to protect it. Even without AES encryption, it's nigh on impossible to hack into it anyway, for a few reasons. One, because the beams are pencil thin. So you'd have to literally get a radio in between the 2 radios, the 2 signals, if you like.
In midair.
In midair, exactly, to try and intercept it. Because, aligning the radios is critical. So they actually have to be literally aligned with one another. You can't just be on the ground pointing a radio in the general direction.
Yeah. Oh, this is why the rain interferes with it.
Yeah.
In transmission through the air, the rain can interfere.
Yeah,
that way.
because the beam arc is so narrow, it's millimeter wave thin, basically. But then there's a few other things as well we put in there. For example, for a start, it's obviously proprietary hardware. So you'd actually have to have a Siklu radio to be able to, interfere.
Oh, that's
if you
interesting.
Or
Okay.
track into it.
Right.
You'd have to know the link ID, so they'd have to actually be paired, if you like. So you have a handshake going on between the 2 radios. I mean, obviously all the password protection, things like that. The ports on the radio you can disable to turn them off, so no one can just like plug in a laptop into one of the ports on the radio to try and sniff it, if you like, try and get the data out. So you can't do that anyway, And then we also do the AES encryption. There's
on top of that, so your basic board is very, very secure, and then you put encryption on top of it.
Exactly.
Oh, interesting.
Yeah, it's a belt and braces kind of thing,
So what's the latest and greatest thing coming out of Siklu? What are we looking forward to in the future? You guys working on something else? It's bigger and better?
Yeah,
Always.
absolutely.
Yeah.
I mean, 50% of the people work for for Siklu are in R&D. So R&D is very, very important to our company, you know. So end of last year, we brought out the 2 gig per second radio, which is pretty cool, you know. So even greater throughput, if you like. Last time we told we only had the 1 gig radio. Now we have a 2 gig radio, you know. This year, we bring out a lower cost model, if you like, of the 60 gigahertz radio. Ideal for video surveillance applications where, you know, cost is obviously an issue with, you know, with security, etc. I mean, people want the technology, but there's always a budget, you know, constraint, for example. So now it's much more affordable, if you like, as a technology. That's a big thing. And we're also going to be launching a longer range product as well over the next few months. So kind of get out of just the 2 mile range. We're going to get more into the, you know, greater than 3 mile range.
Oh, wow, that's fabulous.
So, you know, for longer distances, you know.
So cameras now are moving to this, you know, 2K, 4K, 7K. I mean, a 7K camera. I don't like our little 720p here, by the way. You can see all the sins on my face here, okay? All right, let's just say.
HD.
Right, so I don't need no 7K camera, right? But is that going to be an application that, you know, with those high resolution, I mean, you're going to need 2 gigabytes a second or more.
Exactly.
I mean, by the way, can 2 gigabytes a second, is that enough for a 7K camera?
Oh yeah, I mean
it is okay.
Yeah. I mean, you know, for example, 4K cameras are probably in the range of about maybe. I mean, it depends on, you know, whatever there's certain applications, but you know, 20 megabits per second, for example. You know, 7K maybe a little bit higher. Then obviously you got H.265 coming out, better compression, so they're actually reducing, you know, the throughput requirements or whatever. But even with the 4K, with the 7K coming out next couple of years. Absolutely, you know, no problems whatsoever with our technology, you know, transmitting that type of throughput.
And much more secure. I mean, I could see this. Maybe you're handling the processing, saving, storage, and then I got to get it from here to there. So instead of loading up a whole bunch of terabytes of disks and driving around, I'm going to transmit it to the next building or something. Right.
Yeah. Exactly.
Now, where'd you guys come from, technology-wise?
So the company is based in Israel. Okay. That's where headquarters is.
Good stuff comes out of Israel.
Oh yeah,
and Canada. Those two places have the best stuff coming
out. Right.
So who's the guy that came up with this, and what was the brainchild? It's been around 30 years, the wave. But what made somebody say, you know what, that would be a great application for, you know?
Yeah, well, we started getting into, you know, the small cell kind of market, and we come from the kind of telecommunications market primarily, in providing, you know, broadband connectivity to office buildings, multiple dwelling units, you know, MDUs. The other market we're getting into is a gigabit to the home, you know, actually gigabit speeds to actually houses.
That'd be fabulous.
Like. That's another new market area that we're getting into as well. We started getting security probably a couple of years ago because we saw, you know, the requirement for higher throughput capability because of the HD cameras and 4K, but also problems with interference, you know, and really the growth in video surveillance in urban areas like, you know, cities. For, you know,
that's
public
very big
safety.
now. Yeah, I think we're moving away from physical guards and we're moving towards a lot more technology because the level's there to make it work.
Yeah,
you know, I can monitor a whole building with one guy at a video console instead of having 5 guards walk around. So it works out.
Yeah.
So residential applications maybe are coming down the road.
Yeah, I mean, I'll give you an example. We're working on a HOA community right now. You know, so it's a HOA, homeowners association.
Oh, yeah.
And they want cameras to kind of monitor who's, you know, entering the you know, the HOA, if you like.
There's a few in Calabasas. They are so large, and when I was doing security for them, I couldn't put a wire between the gates, right? Like a mile apart.
Right.
And so now your technology is perfect for that because it's going to transmit all that data.
Yeah, you don't have to dig up the road.
No.
You know, it's much quicker deployment, much lower cost than trying to put in fiber, you know. Also aesthetically pleasing. You know, you don't have issues with large radio antennas. Obviously, people don't want the Big Brother kind of thing.
Right.
So, no, great application for that.
Alex Jordan, Siklu, Siklu.com.
That's right.
Right? And what, Jarvis, what was that? You pushed the button too soon. Alex Jordan, Siklu.com. Thanks for coming in. It's been fascinating. And good luck on your product. Welcome on the show anytime. Maybe I'll see you at ISC West.
Absolutely.
Huh?
See you at ISC West.
Thanks
Thanks very much.
Appreciate it.